Hello everyone, I welcome all of you to Startup Academy, India's exclusive coaching for ISS examination. Since you all know that we have been on the series of solving statistics paper 2, which is of 2026 only, the recent one, and all the doubts and every query of you has been clear. I am doing it in very detail and in good explanation. Even if after this you are facing any doubt, you can comment down below and ask us your question or query, and we will be commenting or replying to your query according to the doubts you'll be having. So in today's lecture, we'll be moving forward towards another set of 10 questions, which is question number 21 to 30. So let us begin. Again, we are taking series A. Those who does not have series A can see look for the question number. The question number might differ, but the question will be same for series B, C, and D. So let us consider question number 21. What does question number 21 says? Question number 21 says that xi's are the random sample from normal distribution with mean mu and variance sigma square, and mu is known. Then we have to consider the testing problems. First is H naught is simple hypothesis versus composite hypothesis, and the second is simple versus composite, and third is simple versus composite. All of the cases are simple versus composite. Then the UMP level alpha exists only for. So I want you to know that this is again an implementation of the theorem. So the theorem says that UMP, which is uniformly most powerful test, level alpha test exists only for one-sided alternative hypothesis. So it only exists for one-sided alternative hypothesis, and here one-sided alternative hypothesis is 1 and 2. So our option will also be 1 and 2, which is option number A, 1 and okay. This is your final answer. Now moving towards question number 22. 22 has given us Bernoulli population. So they have given us that xi follows Bernoulli population with parameter small p. Which of the following are sufficient statistics for p? So let us first consider f x p. What is the PDF of Bernoulli population? It is p raised to the power x 1 minus p raised to the power 1 minus x. Now let us consider L, which is the likelihood. So it will be p raised to the power summation xi 1 minus p raised to the power n minus summation xi. Till here all of you wouldn't be having any doubt. Now from here and from Neyman, Fisher-Neyman factorization theorem, from here and from Fisher-Neyman factorization theorem, we can conclude that summation O of xi is the sufficient statistics for the binomial distribution. Okay, summation xi is the sufficient statistic for binomial distribution. From here we conclude that. Then let us see what are the options given. First option is 1 upon n summation over xi. Now 1 upon n summation over xi, if we consider this is nothing but a 1-to-1 function of this sufficient xi. A 1-to-1 function of the sufficient statistic is also a sufficient statistic. Now, since summation over xi and summation over xi, we have already proved that it is a sufficient statistic, and 1 upon n summation xi is one-to-one function of sufficient statistics, and hence it is also a sufficient statistics. So both these are sufficient statistic, and hence option number 1 and 3 are the correct option for this part, which is option number D. This is your final answer. Okay. Now let us consider another question, which is question number 23. Question number 23 has given some of the properties of MVUE, minimum variance unbiased estimator of a of gamma theta. Okay, so they have also given us that efficiency of gamma theta E less than 1, that we'll be talking about afterwards. So T1, T2 is another unbiased estimator with efficiency this, then which of the following are correct? T1 is the MVUE. T1 is the MVUE and T2 is another unbiased estimator. Now, exactly this kind of question once more they have asked. Previously also they have asked. So same theory will be following. First of all, we know that MVUE is the unique solution. It does not have anything since if I am saying that T1 is the MVUE, then T2 cannot be MVUE. Either it is unbiased or it is less efficient, doesn't matter. Another estimator cannot be MVUE. MVUE is always unique. So they have given us that T is equals to T1 plus T2 upon 2 is also an MVUE of this. So this is wrong because already T1 has been given as MVUE. So another estimator won't be a MVUE. Then the second statement, this was the first. Then the second statement states that variance of T, if they have given us T, the variance of T should be 1 upon 4 variance of T1 plus variance of T2 plus 2 into covariance of T1, T2. This is the formula, but they have here only given that it is T1 upon 4, which is wrong. So hence second statement is also wrong. Then talking about the third statement, they have given us T cannot be MVUE for gamma theta. Yes, it is correct because T1 is already MVUE. So another estimator cannot be an MVUE because MVUE are unique. Now fourth equation says that T is unbiased for gamma theta. If T1 is the minimum variance unbiased estimator and T2 is also unbiased estimator, so T will always also be unbiased estimator. That is the correct term. So T is unbiased for gamma theta, and hence equation 3 and 4 are only correct, which is our option number D for this question. Only equations 3 and 4 follows. Now moving towards next question, which is question number 24. They have given us that x follows exponential distribution with parameter lambda. Okay, now we all know that expectation of x will be, the mean of x will be 1 upon lambda. This is known to us. Then MLE and MME, maximum likelihood estimator and method of movement estimator. So first of all, we are calculating MME. What is MME? If we put x bar equals to the mean of xi. So x bar is equals to 1 upon lambda. So lambda cap will be equal to 1 upon x bar. So we have got this as equation number 1. Now let us talk about MLEs. If we talk about the MLE, then let us write the formula for exponential distribution. F x lambda will be equal to 1 upon lambda e raised to the power minus x upon lambda. Then let us take the likelihood of this. It will be 1 upon lambda raised to the power n e raised to the power minus summation xi upon lambda. Now we will have to take log of L. It will be minus n log of lambda minus summation xi upon lambda. Then we will be differentiating this with respect to lambda. It will, on solving this, we will be getting lambda cap is equals to 1 upon x bar. You can solve this on your own. I'm not solving it. So after that, we will be getting this. So it is our equation number 2. Now, if we see this clearly, the equation 1 and 2, if you could see this, both are equal, and which is equals to option number A. MLE and MME estimators of lambda are equal, which is lambda cap equals to 1 upon x bar, and hence our option A is the correct option for this question. That means 1 only. Okay. Now this is direct implementation. Question number 25 is the direct implementation of a theorem. The theorem states that whenever we have the correlation coefficient, it is always greater than equal to under root of E1, E2 minus under root of 1 minus E1, 1 minus E2 of two estimators having E1 and E2 as their efficiencies. Okay. So if we consider this, here E1 and is equals to E2 is equals to E, let us consider, because they have given that two unbiased estimator having same variance. Same variance means having same efficiency also. So rho is greater than equal to under root of E square minus under root of 1 minus E whole square. So it will be rho is greater than equal to E minus 1 minus E. It will be 2E minus 1 greater than this, which matches exactly with our option number B, and hence our option B is the correct option for this question. Okay. It was easy, just the direct implementation of this theorem. Now moving towards another question, which is also statement based question, question number 26. I hope you can see it on screen. Question number 26 gives us four statements of a consistent estimator. They have given us that Tn is the consistent estimator for gamma theta. Consistent estimator. Now, first of all, first equation says that Tn is unbiased for gamma theta. So, for consistent estimator, it need not to be necessary that Tn is unbiased for gamma theta. So, first statement is no, it is not necessary that it should be unbiased. Now, the second one states that variance of Tn should be less than equal to 1. No, it is not the case, because variance will also can also be equal to 0, just that the theorem states that whenever limit n tends to infinity, variance of Tn should be equal to 0. This is the rule or assumption related to variance for consistent estimator. So our second equation is also wrong. Okay. Then the third one states that when Tn in probability reaches to gamma theta. This statement is the correct one, because this is the probability distribution, probability law in probability or convergence in probability, and this is hence correct. Now the fourth statement states that Tn upon n in probability reaches to gamma theta whenever we apply limit n tends to infinity. So it will be reaching to 0, not gamma theta. So hence it is wrong. And hence only one equation is correct, which is our equation number 3. And our option number C is the correct option for this question. That only equation number C, only option equation number 3 is the correct equation among all the fours. Okay. Now let us consider another question which is based on again Bernoulli distribution. Question number 27. Question number 27 has given us that X follows Bernoulli distribution with parameter capital P. Then the Fisher information based on a random sample of size 1 from this population is. So they have asked us to calculate the Fisher information. For calculating the Fisher information, the formula is expectation over theta delta ln L upon delta P whole square. This is the final formula for this. Now in place of theta, here we can write P because the parameter is P. So this is the equation for this is the equation for Fisher's information. Now for calculating this, first of all we have to write f x p. The formula for Bernoulli principle is p raised to the power x 1 minus p raised to the power 1 minus x. If we take L of this, then it will be p raised to the power summation I 1 minus p raised to the power n minus summation xi. Okay, and if we have to do the log, now here they have given us that it is of size 1. Okay, so if either we are taking log or when we are taking summation of xi, it will be 1 only. So in place of summation xi and n minus summation xi, we can place x because there is only one value and 1 minus x because also there is one value. Now we have to take log of L. Log of L will be x ln p plus 1 minus x ln 1 minus p. Now differentiating this log of L with respect to p, it will be x upon p plus it will be minus 1 minus x upon 1 minus p. Okay. Now we will be taking the square of this term because we require the square of this term. So square will be, first of all let us solve this. It will be x minus xp minus p plus xp upon p 1 minus p. So these two will get cancelled and we are left with x minus p upon p 1 minus p. Now taking the square of this term. If we take the square of this term, then it will be this. Okay. Now we have to find the expectation. Before finding the expectation, if xi follows Bernoulli with parameter p, then the mean of x is equals to p and the variance of x is equals to expectation over x minus p whole square, which is equals to p 1 minus p. PQ it is, so we can write it as p and 1 minus p. So just substituting the values here, we are taking expectation of this. Expectation over p of x minus p whole square, because the denominator doesn't consist any x, so we will be taking p 1 minus p whole square. Now this is similar to the variance formula, so we can replace it p 1 minus p upon p 1 minus p whole square, which will return the values 1 upon p 1 minus p. Okay, this is our final answer of the Fisher's information for Bernoulli distribution, and hence our option number B is the correct option. They have just multiplied p inside, we haven't. That is the only difference. You can multiply it also. So this is your final answer for question number 27. Now moving forward with question number 28. We have given us a random sample. Question number 28 gives us xi follows this. This is nothing but exponential distribution with parameters 1 upon theta. Okay, then the sufficient estimator for this, again by Fisher-Neyman theorem. First of all, f x theta has been given to us as theta x raised to the power theta minus 1. Oh no, this is not exponential. This does not follow exponential. That is my mistake. So this has been given to us. First of all, let us find the likelihood, which is theta raised to the power n summation over xi raised to the power theta minus 1, where I goes from 1 to n. Now by using Fisher-Neyman factorization theorem, let me write it in detail. Fisher-Neyman factorization theorem. If we compare this with Fisher-Neyman factorization theorem, which is g tx theta h x, and here if we compare this, then this is equals to tx. So our sufficient statistics for this will be tx is equals to summation over I goes from 1 to n xi, which is our option number C, which is the correct option for this question. In this year's paper, maximum number of questions included MBUE and sufficient statistics. If you are observing this, being a statistics student, this is the most important thing that you can observe and analyze. So I'm telling you this. Now moving towards another question, which is our question number 29. Question number 29 gives us the most powerful test in testing H0 versus H1 to maximize. We always have to maximize the power of the test. In any testing, we have to maximize the power of the test. So this is a pre-known concept, and hence option number B is the correct option for this question of yours. Now moving towards the last question in today's lecture, which is question number 30. Here they have given us the random sample follows Bernoulli distribution and of size n to test H0 versus H1, the most powerful test. So for most powerful test, let us consider NP lemma. For NP lemma, we have to first consider our likelihood ratio. Before likelihood, let us consider the Bernoulli principle, that xi follows Bernoulli with parameter p. So our fxp will be equal to p raised to the power x 1 minus p raised to the power 1 minus x. Okay, this is our PDF for Bernoulli distribution. Now, since they have given us that it is of sin n, so we will be taking p raised to the power summation xi 1 minus p raised to the power n minus summation xi. Okay, now to test H0 versus this. So under H0, so we can take it as L naught will be equal to P. P has been given to us 0.4 raised to the power summation xi and 1 minus 0.4, which will be 0.6 raised to the power n minus summation xi. Okay, and if we consider under H1, L1 will be equal to 0.6. P has the value 0.6 summation xi 0.4 n minus summation xi. So the likelihood ratio test says that L1 upon L0. So if we take this, it will be 0.6 summation xi 0.4 n minus summation xi upon 0.4 summation xi into 0.6 n minus summation xi. Now we can rearrange these values. If we rearrange these values, it will be 0.6 into 0.6 raised to the power upon 0.4 into 0.4 4 raised to the power summation xi into 0.4 upon 0.6 4 raised to the power n. Okay, and in place of this we can write it as 0.36, 0.16. So the UMP test will be depending on, now if we see this fraction, this is 0.36 upon 0.16 and it is always greater than 1. If we calculate it, it will come out greater than 1. So this fraction is a monotonically increasing in summation xi. We can conclude this, that this fraction is, since it is greater than 1, then it is monotonically increasing in summation xi and hence it only depends on summation xi, which concludes that UMP also depends on only summation xi. So the summation xi concludes the value of this, whether this will change, whether this will give out the most powerful test or not. And hence our most powerful test depends only on summation xi, which is our option number A, which is the correct option for this question. So that was all for today's lecture. I hope that you understood whatever we have done today in the class. If not, you can ask in the comment section or you can WhatsApp us on our number which has been given in the description. Any doubt you are facing, we will solve it whenever we see your doubt. All the best. Thank you.
Welcome to StatUp Academy, India's exclusive coaching for ISS, where statistics meets excellence. StatUp Academy,